Okay, so I think we can start. So hello everyone, thank you very much for being here. This is the research increment number 12, so pretty long run. So for the first time, we are having the research increment open to the entire robotics domain. So we just sent the link to everyone, and it will be open only for the morning session. So the technology transfer activities won't be streamed, nor the planning. But at least the scientific outcomes and planning, the scientific outcomes of the last 3 months, and also the vertical outcomes will be presented to everyone. This is the first announcement. Then we start the update. As always, I go through four main points. So I'll give you an update about the team of the research line, then I give you an update about the projects, then an update about the publications, and then a short message concerning some of the current difficulties that we are having in a specific direction. So concerning the team, as you may know, right now the ANA Avatar X Prize is over. So we have had this joint effort across research axis in the lab, and also somehow inter units at IIT with the support of ICAP Tech facility. And then we had basically internally a team which was called the X team, focused on the ANA Avatar X Prize team, led by Stefano. And probably Stefano will show the outcomes of the finals. But now basically the competition is over. So given also our current new responsibilities of driving the development of the new generation of the ICAB, so we thought of restructuring a little bit the team, which was then split into basically 3 new components. So we will have the first team, which is going to be called Alpha. So the team Alpha, the objective of the team Alpha is to drive the design of the Alpha generation of the ICAB humanoid robot. So the idea is really the sense. The team will implement the sense of the research line. So the idea of combining models and AI and control algorithms to find optimal agent that can interact and locomote in anthropomorphic environment. So the starting points clearly are the work that Carlotta is doing, that Fabio is doing at PFL. I'm sure that he's hearing. No, actually, I'm not sure if he's hearing, but probably is connected. So we have, and also all the work that Giuseppe did, thanks to Adam. And anyway, so we will have a dedicated team which drive the development of the co-design of the new generation of the ICAB, which is called Alpha. So then the second team is the Delta team, led by Giulio. So here the idea is really to implement dynamic, robust, and reactive walking algorithms onto the ErgoCab. So, and this activity is going to be intimately related to the Alpha activities, okay? And this because, I mean, ErgoCab is a next iteration of the ICAB, but we have to understand what is not working for a dynamic, robust, and reactive walking. So the Alpha and Delta teams will work together, okay? So here I'm just putting somehow the Scrum Masters leading the teams, but then there are big interconnections between the two. The third team is the team Tau. The team Tau is basically the team. The core team will be made by Mohammed, and also, do you guys hear the voice? So there is a son that is asking whether or not my voice is clear. So I don't know if if someone can connect, or someone connected
I am able to.
Okay, great. Okay, great. Mohammed can hear us. Yeah. Okay, so then the Tau team, led by Mohammed, will be responsible for carrying activities concerning teleoperation and avatar systems. So we had to somehow reorganize a little bit the internal activities because we got different responsibilities, and the ANA Avatar X Prize is over. Okay, so then the other updates concerning the new team members. So on the 1st of March, we will have Luca Filippo Ferretti. He's a mechanical engineer from Politecnico di Milano that now is doing a master thesis on AI. I don't remember exactly where, if I remember at TH or something or Zurich in Germany. Apologies if I'm getting this wrong. But anyways, he'll be joining the Team Alpha for the co-design of walking humanoids, most likely. Then we will have also Yushan Lu. He is basically a fellow. Actually, he's a PhD. So the story is that the University of Montpellier is hiring a PhD and wanted to somehow establish collaborations with a team, and somehow a team that is renownedly working on locomotion. So Yushan Lu is joining our team as a PhD financed by his scholarship and Montpellier, and he'll be joining the Alpha team concerning the locomotion aspects. Then we will also have Marco Caianiello that is coming back. So Marco is getting back for the experiments on the exoskeleton, and he'll be joining the ErgoCap team. Then we will have Saverio Tagliani. So on this, we still have to understand which team he will be belonging to, either IronCab or ErgoCab. And he'll be doing a master thesis with us coming from Sapienza. And then also Michele Moroni, another master thesis that is coming probably in March. This is not sure yet. And he'll be most likely joining IronCab. So we have to a little bit talk with Gabi to understand the current asset of resources of IronCab to distribute the master thesis. So this is an update concerning the team, then update concerning the projects. So sometimes you also in the TV, you hear, in the television, you hear the word of PNRR, like piano di. Yeah, I didn't write the people that are leaving, only people that are joining. And so sometimes also in the television you may hear the titles like Piano di ripresa e resilienza, so the PNRR, and actually then these things have an impact on us. So there have been a lot of project proposals over the last more or less 8 months, and we have been involved in two PNRR, which stands for, as I was saying, Piano Nazionale di Ripresa e Resilienza, so National Plan for Resilience and Recovery. So the first one is RISE. RISE stands for Robotics, Artificial Intelligence, and Sustainable Environments. And more specifically, this is a big project, okay? We're talking about hundreds of millions involving tens of partners. So RISE has been split into different spokes. Each spoke is basically a main topic, which then internally has specific projects. So I didn't go into the somehow the specific structure of the project. I just wanted to tell you that, yeah, we are involved into RISE, and we are also involved into FitMed-Rob, which is fit for medical robots. So we are involved into these two projects, and concerning RISE, we are involved into the spoke 2, which is this big chunk of activities, and we will be working on human models for and wearable robotics for multiple sclerosis patients. So this is going to be one of our main duties in the spoke 2. And then we are also involved into the spoke 4, where we have to use iField to monitor workers in post environments. So these are basically the two main objectives. Here I put the leaders of these two projects that are really helping carrying out both implementation and management activities. Then we are also involved into the Fit for Med robotics. This is something new that we received confirmation recently, and here the application is once again iFeel for medical applications. We still don't know the exact precise details. We're going to have the kickoff meeting on Friday, so we'll be going to Milan this Friday to understand more precisely what is our role on this. But basically, we have to apply iFeel for medical applications. So these are basically things that you will hear in the lab. Okay, so when we talk about PNRR, or we talk about spokes, or we talk about specific applications of iFeel for medical applications, basically it is because of these two projects. Then last time we talked about our joint lab with Bosch. So this was somehow something we have been long discussing. So the nice thing is that the technical annex was written. There was an agreement between us and the technical Bosch counterpart. It's been a long, difficult story. But the problem is that basically when it got to the legal aspect, it seems that IIT couldn't agree with Bosch and vice versa about the legal agreements of IPs. So right now, basically, the project is over. And I wanted also to clearly somehow transfer this message. So it's really difficult to establish joint labs. Okay, so it's a process that can be interrupted at any step. Okay, so where you hear projects, you hear joint labs here and there. Really, it's a long process that may fail. Okay, and this time it failed because our legal and technology transfer side did not agree with Bosch, and then basically the discussion is over. We're trying to understand if there are margins, but basically it's really difficult. Concerning publications, an update, we got the results from ICRA. In ICRA, we got 4 publications accepted. So the first one is by Venus. So this paper is pretty interesting in the case you want to understand how to combine both joint position velocity and torque control limits into torque controlled robots. So in the case you are interested, please do not hesitate to read the paper. We have to, by the way, do a little bit the repository, so or the dissemination pipeline. The second one is by Lorenzo. So Lorenzo was able to make accept to ICRA part of his PhD results concerning the control approach for human-robot ergonomic payload lifting. So this probably stands the basis for a possible TRO publication. And then we got the accepted paper by Gabri. This was also a nice result. So we were able to to find postures of the robot if a turbine fails. Okay, and by using nonlinear optimization, we were able to basically understand which kind of configurations the robot had to take in the case a turbine shuts down. And then there is also the paper by Mohammed. So actually, this is one of the things that Mohammed presented. I don't remember if last research increment or 2 research increments before, but it is basically the extension of the centroidal MPC by Giulio by considering external payloads and the parameterizations for the contact constraints. So this is also another interesting work that I suggest to read. Then I conclude with a message. So guys, we are struggling with finding people for the jury of selections. So we have a certain number of calls open. I would kindly ask you to somehow participate when asked to the juries for technical interviews. This is really important. Okay, I mean, each of you came inside because someone interviewed you. So, and then we have to basically maintain this pace. So we are struggling with this. And then as a consequence, if the hiring process slows down, then the team's development slows down, and then basically you are more stressed because there are more activities to do. So this is a message I wanted to give you. With this, I am over. So in the case you have any question, do not hesitate to ask. Any question? Any question from the audience? From the cloud? No question from the cloud, I don't know, okay. So I think that now we can move to the next presentation, which is by Gabri. So just a little introduction while Gabri connects. So the Scrum Masters basically are the research line funds the Scrum Master certification. So for Scrum Masters, the research line funds and finances a course that allows you to take a certificate to somehow put a stamp that actually you are a Scrum Master, because we have Scrum Masters that anyways are not certified. So this the research line finances the certification, and for those Scrum Masters that want to take the certification, and Gabri followed the course. So Gabri is going to somehow give us an insight into the course he followed. So thank you very much, Gabri. The stage is yours.
Okay, yes. Hello, everyone. As Dani anticipated, I followed the course for this professional Scrum Master certificate, and I'll try to report in this presentation what I've learned, and also I'll try to connect the Scrum theory with the way we are organizing things in the lab, which is quite close. So it's interesting to see the connections. So the presentation is structured as follows. There is, first of all, I will explain what is Scrum, what are the founding values of Scrum. Then I will tell you how the Scrum team is organized, what are the Scrum ceremonies, read meetings, then Scrum artifacts, that are specific Scrum representation of the work we will see, and then final considerations, like my opinions on Scrum and the way we apply it in the lab. So what is Scrum? Okay, Scrum has this definition that is Scrum is a lightweight framework. What does it mean, lightweight? It means simple. So Scrum is not a big 500 pages manual that explain you line by line how to organize your work. It's just a guideline. Then the rest depends on your environment and the way you apply it. And what does this framework do? It helps people, teams, and organizations to generate value, that is address requests from the company, so organize your work. How? Through adaptive solutions for complex problems. Adaptive in the sense that there is an iterative approach, and it's empirical. So you do these iterations. In this iteration, you inspect the work, and based on previous results, you plan for the future. So you don't have a model that you apply in feed forward. It's based on the feedback you are getting in previous iterations. Founding values. There are 2 fundamental values and 3 so-called Scrum pillars. The 2 fundamental values are already given in the definition. They are empiricism and lean thinking. So, as I said before, knowledge comes from the experience. So you don't have to prepare a feed-forward plan that will go on for years despite what's happening. The plan is built step by step based on the iterations that you do. And lean thinking, so think simple and focus first on the essentials. Don't overthink too much for this plan. Then the 3 Scrum pillars are instead transparency, inspection, and adaptation. Transparency, I mean, its meaning is very clear, because when there is no transparency, the team is led to wrong decisions. These apply at all levels. For example, if there is a person who doesn't open issues, who doesn't commit the code, it's difficult to understand how much the task is done and what's remaining to do. And so it's difficult to plan. And also it's difficult to inspect. In fact, transparency enables inspection. That is, check if the work is progressing towards the goal. How? Meetings. During the meeting, you inspect if the work is progressing. If not, there is adaptation. That is a fast adjustment from deviations. Adaptation is a developer's responsibility, so it shouldn't be perceived as something that comes from the sky. So something is not working, and at the meeting you wait for someone to tell you, okay, you should do this, you should do that. Because Scrum encourages empowering and self-management. So the developers should be able to apply adaptation according to the situation, without waiting for a person who tells them how to move. How the Scrum team is composed. There are 3 entities, and let's say that first of all, the Scrum team is supposed to be a small unit of maximum 10 people. If the team is larger, the team should be split into sub-teams that share the same goal. And the Scrum team is composed by developers, product owner, and Scrum Master. They all work together on the product goal, to reach the product goal. Developers are all people that are actively working on the tasks for the team. And they have some roles. That is, for example, to create the sprint plan, that is the sprint backlog, that in our organization means sprint research increment, and sprint backlog are the milestones that we will plan later on in the afternoon. They agree with the product owner on the definition of done. This is very important because sometimes, especially in our like in research activities, it's difficult to define what does it mean that a task is done, because there is always something more you can do, or points at which you can stop. So it's important that when you define a milestone, when you define a big epic or another task, everybody, including the product owner, agrees that done means reach this goal, reach this level. Otherwise, sometimes it's difficult to understand when to stop and shift to another task, or when consider a task concluded. Then the developers have to adapt to adjust the plan in case it's needed. And because of the spirit of Scrum, that is to be like empowered and have self-management, they also have to be accountable and professional, because with powers comes also responsibility. Product owner. The role of the product owner is to maximize the product value. That means to sell and advertise whatever the team does. And communicate the product goal, that is the long-term target. For example, Iron Cab has to fly is the product goal. Also, the product owner is responsible of the product backlog management. That is the steps that brings towards the goal. And in particular, the product owner is the person who decides the order, the priority of these steps. So if the steps include design the control for Iron Cab, design the new jetpack, design the thrust estimation algorithm, and the team cannot handle all of them at the same time, it is the product owner that says, okay, start with the jetpack design, then the others are ordered with lower priority. Last one is the Scrum Master. So the role of the Scrum Master is more than of advising and teaching, because Scrum Master doesn't mean project manager. There are 2 different roles, and in Scrum theory there is no project manager. So the role of the Scrum Master is mainly to remove impediments that do not allow the team to work properly. For example, I don't know, there are problems in the experiment area on the roof that we have no lights, so the Scrum Master is the guy who opened the ticket asking for if we can have lights, external lights, so that in the evening we can see the experiment area. The Scrum Master helps the developers and the product owners with the planning, because he's like the person who connects the developer and the product owner, so he knows what developers are doing and the product owner has in mind. Collaborate with stakeholders that are everybody else in the organization. Open purchases, open tickets, handle requests for ICAP tech support, and so on. And as I said, he's responsible of advising and coaching the team. So explaining how to open issues, how to document the code, but he's not the responsible of the teamwork, because the team itself is responsible of the teamwork. He's not a project manager, he's just a senpai, a person who is experienced and help the other developers to understand how to work properly. Okay, then we have the ceremonies. Ceremonies are meetings. And in Scrum theory, there is the sprint that is the equivalent of our research increment, but ideally is performed every month, not every 3 months as we do. Is the container that contains all the other meetings. And the other meetings are the daily Scrum, that is the equivalent of the stand-up meeting. We did it in the past, but now I don't think we do it, besides especially a special case in which we need to quickly iterate on the work we are doing. It's a 15-minute meeting that reviews the progress towards the goal, in which the developers review how it's going, basically. Then we have the sprint review, that in our organization is the equivalent of the Scrum Master presentation. So it is when the team, together with everybody else who is invited, reviews the work done during the sprint, so during the research increment, and discuss. Actually, we do it more like a vertical presentation, because there is the Scrum Master presenting all the milestones and the results achieved by the team. In Scrum theory, normally it's more like an open discussion. It's like everybody in the team talk about how it went in the previous research increment. Then there is the sprint planning, that is when in the afternoon we sat down and we decide the milestones for the next research increment. And during the sprint planning, you try to answer questions like, why is the next sprint research increment valuable? What can be done? So you start with the task breakdown, and you start designing the planning for the next research increment. And then there is the sprint retrospective, which is similar to the sprint review, but it is more like from the critical point of view. While sprint review is just reporting what has been done, sprint retrospective is discussing about what went well, what went wrong, and somehow we do it during the Scrum Master presentation, because we also report things that didn't went well normally, but again, it should be an open discussion more than something that is a vertical presentation. Okay, there are also these Scrum artifacts that they look strange, but actually they are just names to represent the work or value, and they have an associated metric a commitment that measure how these artifacts are progressing towards the goal. And they are also easy to map in our organization. There are the product backlog, the sprint backlog, and the increment. Product backlog are all things that needs to be done, ordered by the product owner, as we said before. And this one is basically equivalent to all the tasks that a team has in the Zenith board, including things that are in Icebox and are not currently included in the current research increment. And the commitment of the product backlog is the product goal. So we assume that all the tasks that are in the Zenith board of IronCub, even the one that are in Icebox and we are not focusing now, they are with the final goal of making the robot fly. Then there is the sprint backlog that are things that has to be done during the sprint, so during the research increment. And they are all the milestones and the issues that are inside, they have the tag for the research increment. So they are inside the current research increment. And the target, the commitment of the sprint backlog is the sprint goal. That is a step towards the final objective, but it is not necessarily the final objective. For example, finalize the IronCub 3 design can be the goal of the next research increment for IronCub. And almost all milestones will reflect this goal. And then there is the increment. The increment is a step towards the product goal, but an increment of value, an increment of the work that is done and concluded. For example, when you close an epic or there is a big issue that is closed by the team, and the commitment in this case is the definition of done, which means, for example, calibrate the robot joints. We agreed, everybody in the team agreed in what does it mean that this task is done. Once we did it, we close the issue. That's an increment of value. Okay, so I tried, in this presentation, I tried to report what are the main characteristics of Scrum theory, and I tried to map them in our organization. My thought about Scrum is that I was expecting something more like a product-oriented strategy to be more productive, but actually in the manual there is it's a simple strategy, and there is a lot of human aspects. It's more like encouraging people to be responsible rather than imposing to do this or do that. So it's not bad. And in our lab, I feel like we are quite close to Scrum, but there are a couple of big differences. One is research meetings every 3 months. Sorry to say it, but we are a research lab. Things change very quickly. So 3 months are a long period, and sometimes it's possible that things we define at the research increment become obsolete by the end of the research increment. So this can be a problem. And the biggest difference is that in our organization, we have also individual, let's say individual goals, because there are master thesis students, PhD students. PhD students follow courses. They have to do their thesis. Also master thesis has to do the thesis. So they have individual tasks, not only tasks that are related to the team activity. And despite we try to make the two things converge, that's not always possible. And this means that sometimes this can create stress because you have your own task, and then there is also the team organized as a Scrum team, and there are tasks related to that you have to carry on. And this is somehow difficult to manage. The ideal solution is that the two converge, but that's not always possible. And for this reason, it's also difficult to properly apply empowering and self-management, because if I have to work on my PhD thesis, I work on my PhD thesis, and then if there is the need of helping the team in some other activities, we have to find compromises. It's difficult that you self-manage yourself to say, no, I don't work on the PhD thesis, I work on other stuff. So that's a limitation. Okay, that's it. If you have questions.
Yeah. Any questions? Any question? Yeah, it was. So thank you very much, Gabriel, because it was a really nice presentation. So one of the things that I was thinking is that our implementation is probably closer to what is called in the literature SAFE, which is scalable agile for enterprises. Which is somehow you have different companies that try to advertise Scrum. So Scrum.org is probably the oldest, like the main one, but then there are also these other philosophies that try then to understand how Scrum, which was designed for small teams, can scale for entire companies. And this method, which is called SAFE, then it's basically another implementation of the concept of Agile, and they have these 3-month iterations that they call product increment. Okay, and that's why you see our relative naming, which is associated name, which is research increment. So then probably also other people might also, I don't know if they are interested, might take a look at the SAFE implementation, but it was really nice to see then how this was mapped. The other 2 observations I wanted to make is, yes, Scrum Master is really, you highlighted really nice points. Thank you for that. Another nice, that at least I like, definition is what it's usually called servant leader. So you are really there to somehow help others, people to get managed. And then the third thing was about the retrospective. So another interpretation is also that what Scrum defines as retrospective meetings is what we sometimes call post-mortem or retrospective. So we do it only, we don't do it somehow every time, but only.
Yeah, and on Scrum, they do it for the entire research increment, regardless how it went. Instead, we do it for a specific task, for an activity.
Yeah, exactly. But it was really nice the point you raised before about having individual objectives and team objectives. So be aware that this is somehow a really somehow a difficult but somehow a problem that is always there when we define team objectives. So the job actually. Sometimes my job or Scrum Master job is that of identifying an intersection between the individual objectives and the team objectives where system integration can take place. So this is one of the big difficulties, okay? So finding big intersections between team objectives and individual objectives that we often struggle with, okay? So it was a really nice point that Gabi talked about.
That for that, the only solution is to compromise and try to find a compromise that satisfies everybody.
Yeah.
If possible.
Okay, so no question? Okay, so let's thank Gabri again. And now Gabri talks about the.
I change presentation.
So we are on time. So.
Okay, now I move to the IronCap team plan versus achieved milestone and statistics. As usual, this presentation is organized with first a project overview, then activity in research increment 12, milestone review, and statistics conclude the presentation. So let's start from motivation. Humanoid robots are usually endowed with terrestrial locomotion capabilities. And normally they are good at that, but there are specific cases, for example, complex terrains when there are obstacles and it's difficult to move around, in which humanoid robots fail, or they are not fast, they are slow at moving, at walking, at performing locomotion. So in this context, that can be, for example, a scenario where a disaster occurred like Fukushima or so on, and we need to, we would like to have a machine that can intervene and save people in our place. It would be nice if humanoid robots are endowed not only with locomotion capability, but with contact locomotion, terrestrial locomotion capabilities, but also with aerial locomotion capabilities, which means it would be nice if they can switch from walking to flying depending on the situation. For example, they can cross a terrain covered with debris and then reach the top, the roof of a building by flying, and then they land, and then they operate walking by walking. That's maybe easier while you are operating on the roof. So the motivation behind the work we are doing in the IronCap team is to combine manipulation, aerial and terrestrial locomotion in a single robot, and with the hope that this will increase the robot efficiency in disaster response and pave the way to new applications. The team is structured in the form that apply to the Agile and Scrum organization that I presented before. In particular, there is the axis aerial humanoid robotics, and we have two main components, component IronCab and component aerodynamics, that work on the goal, towards the goal of making the robot fly. In this research increment, we added a new repo that is Fabio's repo for his period abroad, element co-design morphing drones. So what happened during this research increment? One of our papers we submitted got accepted to ICRA. Unfortunately, the other paper from Osam, no, so we are planning to resubmit it to IROS. We performed a wind tunnel experiment. We went at Politecnico di Milano with the robot, and we tested it in the wind tunnel. And also, we started working on the design of the next IronCab, that is IronCab 3, based on ICAP 3. Okay, milestone overview. This research increment is kind of strange because compared to the beginning of the research increment, at the end we got an improvement, an increased number of issues closed from 87% to 90%, so 3% of increment, but the number of story points decreased. I think this is because at the last research increment, there were a lot of milestones that were about to be closed. So at the last research increment, we decided to close all of them, do not add them in the next research increment, and open new milestones. And since some of them are heavy tasks, like design the new iron cap tree, the number of history points is higher, and that's why it decreased in time. So it means we have a lot of big issues that we still didn't close because we just opened them in this research increment. While we started fast iterating on some design issues, and also there were all the issues related to the wind tunnel that we closed. And so we closed a lot of issues, but the issues with big number of history points are still there. That's the way I explain these differences between the percentages. Checking more in details the team activities, starting from hardware design. We have two tasks at the moment. One is to validate IronCab MK2 and design small modification for IronCab MK11, because until IronCab version 3 is not ready, we are still developing for the previous version. And in particular, the fuel tank just arrived like a few days ago. So we finally have the tank on board on the robot for untethered flight. And then there is another activity that for now is in parallel, that is about the design, the prototype, and all components for IronCab MK3. Here, I think that there is nothing unexpected, because for MK2 and MK11, we are going towards the closure of the development. So for now, there are some issues that we are tracking and we are trying to close, but there is probably there won't going to be new issues opened. So this is just cumulative until it's closed. And instead, for the design of IronCab MK3, the number of issues increased. We didn't close all of them, so then the percentage of completion of the milestone decreased, because we are still in the task breakdown phase. For what concerns aerodynamics, we have CFD simulations carried out by Antonello. And the main tasks were to analyze the data from the second wind tunnel campaign, which is almost done at this point. Design a whole body controller that accounts for aerodynamics. In December, we started the discussion. There were a couple of issues open, but we are still discussing how to implement this controller. And prepare a publication that had a huge step forward, because we closed all the issues related to the wind tunnel, and also we started accumulating results for the publication. So this one had a big step forward in this increment. Then there is morphing covers that now Fabio is doing his period abroad, and he's focusing on trajectory optimization and co-design for a morphing drone. Oh, that was fast. Okay. So the idea is to implement a co-design framework for morphing flying drones. You see the milestones here, and it's progressing towards the end, because Fabio is almost done with this period abroad, and he would like to finish his activities there. And also solve a trajectory optimization problem for morphing flying drone that is a sub-activity of this main milestone. And also that one is almost done, as you can see from the results. Planning and control. On this side, we have transition maneuvers. We are focusing on automatize the takeoff landing procedure. And there were two milestones related to improved joints low-level tracking that was necessary because we have big issues with the 2.5 robot because of the tendon-driven shoulders. They tend to lose calibration, encoder calibration, and also gain tuning is not easy because if you are too stiff, the tendon broke. So we perform some sessions to tune that, and we are almost done. Actually, I think the other issues can be closed. And then there is another activity related to implement MPC controller to stabilize the planner trajectories. For now, in IronCAP, we focused on instantaneous controllers, but we would like also to explore this possibility. And this one is, the idea is to try to finalize it in the next days, in the next weeks, so that also Giuseppe can leave for his period abroad without this. Is not blocking. You can leave in any case, but we have a first version of the MPC controller to test meanwhile. Then another activity is to port these planner and MPC controller simulations from MK11 to MK3, that is the new robot version. And in this case, we started working on there are some issues related to that. We started running some simulations. Modeling estimation. For modeling and estimation, we have all the activity related to base estimation, FT modeling, and let's say advanced trust estimation strategies. That are, and these issues, we open the following milestone. There is improved momentum-based trust estimation by adding constraint and moving horizon estimation. This is when I was referring to advanced strategies for trust estimation. So we are trying to use robot information combined with the jet information to get a more accurate estimate of the trust estimation with respect to what we can get only from the jets. And this was a new milestone that is progressing. Validate the FT nonlinear calibration model. This is related to previous activities that we did concerning FT calibration. And this one is also progressing. The idea will be that we use these nonlinear models also in IronCAP 3 for the trust estimation on the arms. So this one is an activity that will go on also for IronCAP 3. And the last one, integrate and test Vive trackers in the MK11 setup and identify base pose estimation solution for MK3. So base estimation, base position, and velocity estimation is difficult. We are struggling with it. At the moment, the best solution we have seems to be to use the Vive trackers like Telexistence guy are doing they did also for the Unavatar. So we are testing it, and we are also meanwhile trying to understand if there are other sensors that we can buy for IronCAP 3 and put them on the robot since the beginning this time. Jet engines modeling. Here the focus is still on thrust estimation, but also on jet engine modeling and control. The idea, the milestones that we opened were related to performance sensitivity analysis, because we have this feeling that simulations are not so close to reality, especially for what concerns the jet engine modeling, which we didn't really progress on it, but this is biased because this is actually what I was referring to before. During the iteration, we changed direction, and we decided to move towards a simulation of, which actually is related also to the second milestone, to move to a simulation of the jet engines using neural networks, the physics-informed neural networks. So both this milestone and the one below, build the dynamic jet engine models and import it in Gazebo, will change now because we are focusing on this physics-informed neural network design for the trust estimation. And then validate and refine the RPM-based AKF to estimate orbit thrust from RPM. This is still ongoing and it's progressing. It's an activity related to thrust estimation, but using only the jet engine information, and is the current thrust estimation strategy that we are implementing, and we are still working on it, also for IronCAP 3. Experiments, last one. So perform the first flight. It's still going on. I think it became a very big milestone with 510 issues. So probably this is going to be its last iteration, because now we stop it and we change the objective. We'll see, I think. Which will remain to perform the first flight, but we rephrase it in a different way. And then prepare the experiment setup for IronCAP MK3. This is a new milestone because not only we have to prepare the robot, but also the experiment area needs to be updated. So we need to work on it. We started opening issues, but for now we didn't progress a lot. Okay, quickly on statistics. Flow of issues more or less remained similar to the previous research increment. The number of closed issues is huge this time. It's higher and we are less, so closed issues per contributor are almost 30. I think is related to what I was saying before. There were a lot of small or experimental related issues that we closed. And that's why there is this high number of issues closed. Control chart, it's better than the previous research increment. We have a better average and rolling average. There are still a lot of outliers because we closed big issues like wind tunnel related ones. Long issues that were there since long time. Burn down reports looks okay. The one that is coincident with the Christmas holidays is a bit flat. The one in January, I don't know what happened, but the others seems okay. And release report is also okay. More or less, it repeats what I already said about issues and history point, this mismatch between issues and history point. Okay, that's it. Thank you.
Thank you very much, Gabri. Any question? No. Okay, we are a little bit late in time, so we have to recover. Thank you very much once again, Gabri. So I'm going to put a timer on 13 minutes so that the speaker is aware when, yeah. No, also Gabri had it. The sound should be not too invasive, let's say, because having a ring bell. Okay, great. Yes, Punit, thank you very much.
Good morning, everyone. So today I'll be presenting regarding the development of IronCAP from MK0 to MK3 and further beyond. So as Gabri has already explained, I just want to go briefly on this. So IronCAP is a project where we are actually trying to develop a new frontier platform by combining bipedal terrestrial locomotion, aerial locomotion, and manipulation. You can check out more on the website if you want to. So moving on to the actual presentation, what will make the humanoid fly? This is a question we asked so many times, and frankly, the answer came out to be a miracle. And since we do not have this in plenty, we went on with the next best thing, the teamwork. And we do have a very good team that's well versed in hardware and implementation of effective control and estimation. So my presentation will more focus on the hardware implementations on the humanoid robot to make it fly. So what do we need for hardware? We need engines that actually give enough thrust to make it fly. And we need the fuel systems that actually can provide the fuel, obviously, and power sources that can power the like batteries and other things to power both electronics, the robot, and the turbines itself. And safety systems like safety valves, which we need on the fuel line. We need some shut-off buttons in case of some emergencies, and also some thermal protective devices so that the entire equipment is safe from fire hazards. And telemetry, obviously, where the data is being continuously recorded and then transmitted for processing later and development, assist in our development. So a brief introduction about the turbines that we are using. We are actually using JetCat turbines at this point. And the turbines that we have explored until now in our project were P100, P160, P220, and P250, Pro 250. As the number suggests, they are actually the amount of thrust each turbine provides. The reason we use these is actually they have a very good size to thrust ratio. They have a very small size, and they give enough thrust to actually lift a very huge load. And they require very limited power, a 12-volt power supply to start the motors. And they have the capability to be fueled by two different fuels, jet A1 and diesel. We tried both, and currently we are sticking to jet A1 fuel, kerosene. And they have an integrated ECU with which can provide the RPM, throttle, and exhaust. So more or less, it's kind of a plug-and-play device. And they have also been tested widely and used. So currently, we are with something that's reliable in usage. So regarding the experimental setup, as I said, we are using turbines. I think we cannot work with these inside, so we had to go outside the confines of the laboratory. So we had to design our own experimental setup. And as you can see, we started with this kind of an experimental setup where we have just that robot, no upper, lower body, and just turbines mounted. And as you can see, it's very, very preliminary. We had to progress towards a little bit better looking experimental. It's still not really a great experimental setup, but still we managed to publish a paper out of this experiment. And as you can see, the lower body is covered with some thermal protective pans to safeguard it from fire. And then slowly we progress to a more customized experimental setup. And as you can see, we have, and during all these experimental setups, we have actually progressed towards the implementation, and the time to implement the setup has decreased widely. So it has been decreasing as we go on. In the beginning, I think it was 6 hours. Now we are at 1 hour, I think. So moving on to the current setup, as you can see, it's very customized. We can actually plug and play as fast as possible. And we have been operating in different climatic conditions and also times of the day. So more or less, it's very reliable in this sense. Moving on to the reason for the hardware that needs to be this one, it needs continuous improvement. And as we can see, and my most favorite thing, it needs to evolve. So the most main reason and the most important factor that we need to consider while doing an improvement is safety. And also during our experiments, we also noticed that we need another factor that we had to improve, but we had started with P100 turbines and slowly we had to progress towards a higher. So we need more power. And the next thing is just having power is not enough. We need better control. So every time we did some improvement, the control had to improve too. And as I said already, we had operated in a lot of weather conditions. We were in winter, we were in summer. There were so many issues. We were freezing, the robot was freezing. So we need something very, very robust. And something that always happens with such kind of violent experiments, I would say, is breaking of something. So we need something that needs very fast maintenance. So we have been improving in the design such in keeping this in mind. And of course, the last thing is, as I was saying, the time that requires for doing all these things needs to be reduced. So we need something that's easy to assemble as fast as we can and should be integrated fast. Moving towards the actual evolution of Iron Cub. So we started with MK0, which was, as you can see, a very preliminary design with turbines put everywhere. And then we went to MK1, which is more or less the one that you saw in the videos. And then we progressed towards MK11. It's an intermediate version, which I'll be explaining further in the next slides. And currently we are about to test MK13 right now. And just to mention, the size of the robot remains same. I just wanted to show that it was evolving. I mean, the robot did not grow. So MK0, so it was a very initial concept. There was not much to be realized in a real scale. And then it was to just to understand the feasibility. So, I mean, not much to tell about it. It was just integration of turbines with the robot. And the next thing is MK1, which is the first realized prototype that had a jetpack and four-arm turbines. We used 300 turbines on the four-arm, and jetpack had P220 turbines. And we also had to integrate some new parts like a titanium spine in the robot to withstand the load of the turbines that's coming from the jetpack. And for base estimation, position, and orientation, we had to use Aruco board and also the IMU integrated already inside the robot. So talking about the advantages of this model was it was the first full-scale robot, and we did have some good results and insights into our implementation. So we understood our idea a little bit better in this case. But there were a lot of disadvantages too in this case, and the turbines, especially the P100s, was a major disadvantage because they had slower dynamics and they also had some issues with startup, especially during winter. They never started properly. I remember those days where we were trying to pump the fuel somehow. And the Aruco, on the other hand, it's since again the experimental setup is outdoors. Aruco is something that works during with better light conditions, and light conditions change outside and according to the climate, the time of the day. So it was a little hard to have a very good, reliable result from this technology. So we had to move towards MK1, and also the idea was to move from MK1 to MK2, where we were supposed to go for a tetherless flight. So we started developing intermediate models. So one among that was MK11. As you can see, we first tackled the problem of P100 turbines. We went towards P160 turbines, and the jetpack we had to redesign. As I was saying, also the easier integration and assembly, we wanted to make some few changes for the electronics on board. So we made these changes such the jetpack electronics changed a little bit. And instead of using Aruco, we started using the RealSense camera, which was mounted on the chest, and which also has gotten its own IMU. So integrating with the IMU, it would give us better results. And also we progressed towards using a V-Way tracker too, as Gabri was mentioning earlier. This is actually ongoing. We still haven't tested full scale, but we are actually going on through it. And with this, we might achieve a good pose estimation, maybe base pose estimation, hopefully. And also, as I already mentioned, the endeavor is to go towards a tetherless flight. We went also try to put the batteries that power the turbines on board the jetpack electronics. So that paved way to MK13, which is supposed to be tested. I mean, we have the hardware, everything ready. We need to test. I think in the following experimental campaign, we might be testing the assembly on this one. And also we made changes to the robot battery such a way that the safety valve can also be on board. So it can power the safety valve, the battery itself, the robot battery itself. Talking about this, and also as Gabri mentioned recently, we received our fuel tank. So there was always an endeavor that was going on to develop a complete tetherless flight where there is the fuel systems on board, there is the batteries on board, and there is no other cable connecting the robot. So independent flight capability. So as you can see, this was the initial design. We designed a frame for the front tank and the back tank, and we went with individual supplies for both front and back. The front tank arrived around, I think, 6 months ago, and it's quite small. There were some issues in manufacturing this because of the shape, complicated shape, since it has to be mounted onto the chest. Instead, the back tank has got more of a regular shape. It's like a quadruped, a square kind of this one. So it was easy to manufacture. It was not as fast though. So as you can see, we have finally been able to mount and realize both the entire MK2. So we still have to test it. Maybe we have to plan some experimental campaign on this, but more or less it has been achieved. But there were, as I was mentioning, there were a lot of challenges that we have been facing, and one among that was the cable-driven joints. We had so many failures of joints due to breakage of cables, some loosening of cables, there were some tracking issues, and so on. There was this effect that we were not really able to explain called the ground effect. We still are postulating on this. We are not pretty sure that this is the one, but there is a problem when the robot height is a little, I mean, the iCub robot is not too tall. So there is a kind of fountain upwash that comes, which is heated hypersonic, supersonic wind that comes up when the turbine is pointed downwards. And the P160 turbines really did not improve a lot. It had faster dynamics than the P100. 1 minute. Okay. So I'm going a little faster. So P100 better than P100 turbines, but it still had startup issues. We needed better sensors, and the space was limited. So we went towards the MK3, where ICAP 3 possibly can give us solution. I mean, can bring us better results. So it was a third prototype and uses ICAP 3 platform. We decided to use all P220s, so we do not have any other this ones, and also use Pro 250 turbines, which are very, very good in as advertised. I'm not sure. Has an inclination in the jetpack turbines, which we are actually postulating on this might give us more stability in flight and control too. And since we have been estimating, and as I was saying, we need better sensors, we have decided to integrate a load cell into the jetpack that can actually measure the thrust being given by each turbine. And then for the base force estimation, instead of going with Aruco real sensor, we also thought to buy an dedicated sensor that has an IMU and GNSS satellite support that can give us kind of a GPS data. So that way we can actually measure the entire thing. So talking about the further improvements, MK3 is in progress. So we are more or less going towards complete implementation of MK3. We are also planning to go with aerodynamic studies into the design that Antonello is doing. So sooner or later we would be there. We are also trying to achieve natural flight dynamics by implementing some morphing cover technology into the robot. And of course, to develop a hardware intelligent framework that can probably solve most of our issues. I believe I was on time.
Yeah. Thank you very much, Punit. Really nice presentation. So yeah, I really like the, and I'm gonna copy it. Okay,
Okay.
miracle, and teamwork paradigm. So any question for Punit? So, as you may know, Punit is starting his PhD on hardware intelligence applied to the Iron Cub. So I'm sure that we will see how then actually the robot evolving also in dimensions. So if there is no question, so we go to the next speaker, and we thank Punit once again for this great presentation.
Okay.
So Stefano. So I put this timer on 13 minutes, but it's incredible to see how the clock gets diverging in 30 minutes. I had to fine tune it along the way. Synchronization issues. With the internet is we're done. Okay, so Stefano, the stage is yours.
Okay, so well, good morning, everyone. I will presenting the outcome of the Skoldex team, which is a team composed of many people, or at least was composed of many people, and was composed of people coming from different groups. So it was really an integration team. Moreover, we were very well supported by AgapTech. In particular, we had all the support of Team Fix that really helped us in getting toward basically our mission. That was to integrate algorithms and technologies on a walking humanoid robot toward an advanced avatar system for participating to an Avatar X Prize competition, at this point, finals. So the finals were held in November, at the beginning of November, in Los Angeles, in Long Beach. And we had the robot there on the stage, which was themed over a Mars exploration. So the goal of the competition really changed over time, going from an avatar person interaction up to avatar for heavy duty tasks. Nonetheless, we iterated a lot over also the hardware of the robot, and we had the robot there on this huge stage, walking completely wireless, while being teleoperated by an operator which was naive, which was trained in actually 10 minutes, because then we had different issues with hardware, network connection. But still, she was able, not too much with ease, but she was able to control the robot movements with the devices that we developed in-house. So this, I think, was a great point of our team, that we managed basically to develop a lot of hardware, a lot of technologies into the avatar system. So you can see here, well, this was the first attempt of raising the bar, raising the switch, that you can still find the avatar in the robot room. Please don't use it because it's super noisy and it's super annoying. So she was able to pull up the switch, which was actually the second task. And then she had to walk toward the door that you can see with all the lights on the right, close to the man with the red jacket. So there was really a lot of walking, and we were at the end we were the only humanoid robot able to walk on stage. There were other humanoids, but they either resorted to wheelchairs, basically. So they see the robot on a mobile base, and they were using mobile bases. They were all wheeled robots. And then there was another robot from Japan, which crashed. Now you can see that unfortunately the aiming wasn't very well for this operator, and you can start seeing on the bottom right that there is the clear shadow of the robot on the door, and then you can imagine what happens if you keep pushing toward the door. So yeah, she also was a bit in doubt about whether to continue or not, and she thought, oh yeah, I can do that, but yeah, reality check, she didn't. So yeah, the robot was pretty stiff. Unfortunately, she hit the part of the door stage with the one hand, and being very stiff, this caused the robot to bounce back and to fall, which was very similar actually to one of the things that happened while testing with Silvio a few days before. So we hope that didn't happen. Unfortunately, we tried to take some action in order to make that easier. But still, the operator didn't think about looking at his arm. We mentioned that he was able to look at the feet, he was able to look at the body. She thought that she was able to pass, but she didn't. So yeah, it was a bit of a bummer for us, but nonetheless, it was very, believe me, I was there, and it was so awesome to see that I was walking there with all the lights completely there. So it was in the end a huge experience. So moving very fast to the milestones. So we actually had one milestone for the competition. It was to participate to the finals, and yeah, so it's done. So I didn't resist to put a meme at the end of the project. Sorry about that. So moving on, and then the competition, it was like the driving force of the team. It was not the only one. We were a research group, so we had also a bunch of other activities that we want to pursue for what concerns research part. So we had first, for what concerns VR and teleoperation, we wanted to improve the teleoperation system by, for example, having some spherical rendering in VR that will better adapt with the fisheye on the robot cameras. And this is arriving. We need to test it on the robot, and it has been tested in standalone tests. And we thought about using a 3D engine to visualize VR content, but it's something that actually we steered away from this direction. We adapted to a new direction, so as Gabriel was mentioning before. So we want to use the wear gloves in place of the sense glove. It is really arriving. We haven't used it really in a demo yet, but the code is there. We just need to conclude a few things, but it's working. We tested it with the robot a few with Essen, and you can see that the system is much simpler. It takes less time to be worn. And of course, it's less precise compared to sense gloves and cannot control the fingers separately, but it's really is working fine. Is very promising. Moving on, the second part was related to locomotion. So we wanted to start using the ergo cab, but actually the robot will be available starting from February. We started starting some planning activities, but it's something that will come in the next few months. Then we wanted to adopt complex trajectory generation techniques, and particularly we want to test the offline adherent pipeline to ICAP3. This was a part of the Riccardo Zuppetti's thesis. And we do have some interesting results also with ICAP3. You can see here the robot is walking sideways, is also walking forward, and this is exploiting the trajectory generation pipeline that starts from the human, then passes through machine learning techniques, and then up to the generation of joint positions for the robot. So in this particular video, they were testing some mixed, Paolo and Riccardo were testing some mixed motion directly on the robot. So this is also a very interesting preliminary work. So yeah. So we also wanted to have a line generation of adherent trajectories of a line generation of trajectories using adherent. This activity started. It took a longer time than expected, also because of technical difficulties in implementing all the tools. And then we want to use centroidal MPC in the working pipeline. This is something that we are actively working on. It's something that will come in. We starting adopting more and more pieces of code into the working pipeline, and we're getting there. Then we want to connect the two parts, but this also will come as soon as we're able to close all the previous dots. Another point is the whole body planning with uneven terrain. This is the work of the Roberto's thesis. And we are very close, so we have here the robot balancing with a nonlinear planner on a step with a foot on one step. We are going toward the generation of trajectories to actually take the step on the step. Moving on, for all concern estimation, we want to implement and test gamma filtering for torque estimation for the entire robot while on the pole. We are actually pretty close with that, and Ines will discuss about that more in detail later. We're very happy about it. And we want to have a first steps to have a floating base estimation, and Julia actually started working on these activities in these days, cursing again against the real sense. And for all concern logging, this was the work of Nuno that left at the end of the year. So we want to start submitting some to NASA, some of the changes that is done on the plotting, and this activity started. So the process of getting things merged on the NASA side takes a long time, so it's a long activity that started. We want to have the robot visualized on OpenMCT, but it's something that at the end we decided to postpone, and it was less important given the short timeline. And we started making. We want also to make specific configuration for the robot and changing ports and whatever easier, but it is also something that we decided to reduce. But instead, we have predefined panels available, so we can define the panels once, and then are available to all the devices that will connect to a web address. So basically, with your phone, you can connect, and you'll be able to see the joint tracking, for example. This is pretty cool. Manuscripts. We have the PhD thesis of Paolo, which is actively working on it. I hope he was able to get his head above the PC, off the PC lately. And then we also have the master thesis of Roberto, which is something that started, while Riccardo Zuppetti actually graduated. Then we have we want to write a paper on the teleoperation pipeline. It is arriving. We are iterating with the authors, and it's almost there. And a paper on the parameterization of friction cone, but it's something that unfortunately got delayed but because of many other tasks. Then flying toward the statistics, then basically we started closing a bit of issues. So you can see on the right that there is a huge peak, a big peak, and we actually started cleaning up the boards in view also of the next reorganization. And we can also see that after the demo, I mean, there was the initial period on the right where we were about to fly to Los Angeles, so that nothing was happening. Then we started closing issues. Then nothing was happening because everyone, of course, was in vacation. Then there was Christmas, and then we started closing again issues at the end. Estimated scope is closer to 100%. We are still closing issues in these days. And here the board downs again, you can see that during October, we basically started closing a lot of issues because we already shipped the robot we were about to fly. So we closed 130 history points. Then basically nothing, I don't know, yeah, basically nothing during the first week of November, we were in LA. Then nothing later. We started closing just after coming back. And also, yeah, we started closing a lot of issues just lately, and it's done. Okay, so final remarks. I would like to really thank the team. It was really a great experience, and I'm very proud of what we did. I'm very proud of having the chance of driving a little bit you guys toward the goal. It was really great what we did together, and really I'm super grateful and super honored. So thank you very much.
Thank you very much, Stefano. So any question or comment from the audience? I just wanted to say that, I mean, it's been an incredible job. Okay, so the team and also an incredible experience. We have been through a certain number of challenges, okay, that we had to really try to face quickly, find effective and quick solutions. So I wanted to thank all the team, the ICAP Tech and Stefano in particular, for all this great effort. I think that we somehow, now the effort was so as we were able to gain so much knowledge about the system, how the system works, that it is a step towards shared autonomy and full autonomy. So I think that all the work that we did now, it's enabling somehow, if you want, a level up of the intelligence of the robot, because now we can basically move from teleoperation to shared autonomy to full autonomy of the robot, thanks also to the new research projects we have. So really somehow the metamorphosis, if you want, is never let's say easy or not painful. So in order to evolve. And so Stefano, once again, thank you very much. I just have one question for you. Okay, so if you had to tell something to yourself of 3 years ago, what would you tell yourself?
Okay. So I want to be cheesy, so believe in the team. So yeah, it's really the core strength of everything. Let's went through all the difficulties.
Okay, so let's thank Stefano again. Now we move to Ines. So I will also put the timer. Okay, so Ines will be talking about sensorless whole body torque estimation. So Ines, the stage is yours.
Okay, so good morning, everyone. So yes, I will talk about the work I'm doing for my PhD project, and in particular, the first part is focused on the sensorless full body torque estimation. So I would like to start from what we have right now on our robot. So this demo is a whole body torque control demo performed by Giulio in the past. And basically, these are the maximum performances that Giulio was able to reach on ICAP 2.5. So as we can see from this video, the robot is very shaky and the controller seems to be unstable. But why? So the torque controller is closing the loop on an estimation of the joint torques, because as you know, we don't have joint torque sensors on our robot, so we need a joint torque estimation. And the algorithm implementing this estimation is a deterministic algorithm. But which can be the problem? Why we have this behavior? We can have different sources of errors, which can be related to measurement or process. For instance, we can have sensors that are miscalibrated, or we can have drift or noise on the measurements, or errors related to the process can be, for instance, modeling uncertainties. So just to give you a big picture of what is running on the robot, we have an high-level planner that is planning a trajectory in the task space, which sends the desired trajectory to a high-level whole-body torque controller. This torque controller generates desired joint torque trajectories, which are sent to the low-level joint torque controllers running on each joint of the robot. This controller has the aim to track the desired trajectory and generates desired motor currents, which are sent to the motors of the robot. But we need to close the loop on this for these controllers. And for doing that, we have an whole-body torque estimator, and it would be happy to have also a robot-based estimator, because the robot-based pose and velocity are useful to know where the robot is in the space and how the base of the robot is oriented. And basically, my work is focused on the block that is highlighted in red. For the time being, as I already said, we have a deterministic algorithm, but we would like to take into account all the source of noises we can have on measurement and process. And for this reason, I would like to replace the deterministic algorithm with the stochastic estimation. So I started analyzing data coming from all the sensors available on the robot. So for instance, here we have the measurements of the force torque sensor mounted on the right upper leg of the robot. In the case of the force in X and Y direction, we have an error of, for instance, in this case, up to 20 Newton. So this means that we have calibration problems on the force torque sensor. Analyzing also data coming from the motor current sensor, we can see that the data are very noisy. And also in the case of accelerometers and gyroscopes, we have drift problems and very noisy data. So, which is the idea? The idea, as I already said, is to use a stochastic approach and also a sensor fusion approach. So we want to use all the information coming from all the sensors available on the robot. And we want to start from the entire model. The idea is to take the model and split it in DFT sensors. In this way, we can have a set of submodels. But why we do that? Because in this way, using the measurements of the force torque sensors, we can have information of the forces that the submodels are exchanging. So we can use these forces as external contacts per each submodel. And in the end, propagating these external contacts and using the model, the dynamic model of each submodel, we can estimate the joint torques. So, as mentioned before, we want to use a stochastic approach. So I decided to go for an ascending Kalman filter. And just to give you a shortly an idea of how it works, basically, if we consider the state variable and its Gaussian distribution, the filter basically selects a set of points from this distribution, which are called sigma points. And then these points are transformed by using a nonlinear function. Basically, the nonlinear functions are the functions describing the process model and the measurement model. And in this way, we obtain a new set of points, and we can approximate them with a new Gaussian distribution. from which we can compute the mean, the new mean and the new variance. The new mean will be the new predicted state. So which are the process model and the measurement model in our case? So first of all, the state vector I'm using contains the joint positions S, joint velocities S dot, the motor torques, the friction torques, the force torque branches, and the biases of the accelerometers and of the gyroscopes. And basically we have here the dynamic model describing the process. And basically I just used all the information we know from the theory, so the dynamic model of the robot and information coming from the physics of the robot. As you can notice here, for the motor torques, friction torques, force torque branches, and biases, we have that the derivative is equal to 0, because basically we don't know which is the model of these variables. So we just consider them constant in time. Instead, the measurement vector contains all the measurements available on the robot, which are the joint positions, joint velocities, motor currents, and linear accelerations from the accelerometers, and angular velocities from the gyroscopes. And also in this case, the equation describing the measurement model are all the equations from the dynamic model of the robot and from the electromechanic theory related to the motors. And okay, how did I test the filter? Okay, basically the idea is to run experiments on ICAP3 and starting from a fixed base configuration. I generated a random trajectory, and actually I generated this trajectory, a trajectory in the task space, and I ran the trajectory first in simulation, because in simulation I could use the torque controller available on the simulator. In this way, I can have a ground truth or the joint torques. Otherwise, I don't know how to compare the estimation, how to validate the estimation. And then from that, I run the corresponding joint position trajectories trajectory on the real robot, using the robot in position control mode. For the first test, I didn't consider external contacts. So here are the results of the estimation. I'm not showing the estimation of all the variables, but just the variables we are interested more, which are the joint torques. So actually on the left, we have the estimation of the motor torques. In particular, in blue, we have the expected values, which are computed starting from the measured motor currents multiplied by the gearbox ratio and times the torque constant. And in orange, we have the estimated values. Instead, on the right, we have the joint torques. Actually, as you notice, we don't have the joint torques in the state vector, but from the physics, we know that we can compute them as the motor torques at the joint side minus the friction effect. And actually, the friction torques are part of the state vector, so we are estimating them. And comparing the estimation of the joint torques in orange with the expected values coming from the simulation, we can see that they more or less match. Of course, the estimation can be still improved by performing a better tuning of the covariances. So, which is at this point the future work. I would like to estimate to run again the estimation, but this time with also external contacts. Then, since the friction torques are used for computing the joint torques, it would be good to have a friction model in the process model equations to help the friction estimation. And then, okay, I didn't mention it, but the filter right now is implemented in Python and is running offline after acquired data. But it would be great to have it to have it online. For doing that, I need to re-implement it in C++ and integrate it with the current architecture. And after that, we need to tune the filter covariances together with the torque controller gains. Why? Because we can also have a perfect tuning of the covariances using only the estimator, but then as soon as we close the loop, things change. So it would be good to tune the covariances together with the torque controller gains. And in the end, it would be nice to extend the implementation to a floating-based configuration. Actually, the implementation is already also for the floating-based case. The problem is that there is some information missing that is related to the robot base pose and velocity. This concludes the presentation, and if you have a question, I'll be happy to answer.
Any question? Yeah, I actually have. So this is a very nice preliminary work, Ines. So I think that for the Delta team objectives, it's really somehow in perfect trajectory for the torque control. So one of the really interesting things that you mentioned is if you can get to the this is basically the last one, because probably, I mean, yeah, tuning together the covariance of controllers, I think it's a really nice idea. Yeah. On top of this, we might also think of if we have to design alpha, then we might for the walking. Just to make you concrete examples, so we might optimize not only controller parameters, not only body parameters, but also covariances of estimators. Okay, into the co-design loop. So this is somehow an interesting question. So we not only have controllers, but also estimators parameters that can further, yeah. So, okay, any other question, observation? No? So let's thank Ines again. And we are incredibly perfectly in time. So please, let's try to get back at 11:27 at most, so that we start at 11:30 for the presentation. For people connected from the cloud, so the increment will restart at 11:30. And now coffee. I pay coffee for those who want coffee. So. Giriamo pagina. Pronto? Who's next? Yes. Yes. So it's 11:28. So we have 2 minutes to go. Lorenzo Rapetti is preparing the presentation. So just for the cloud to be informed. What is all the rest? I think that we are. So you will hear this noise. It's not too invasive. Yes. It's not too invasive. Cosa? Ah. Che poi non è neanche minimum path, cioè è maximum path, maximum energy, cioè è quella dal punto di vista evoluzionistico meno. Yeah. Ok. Funziona, Lorenzo?
Si è spento, non so se non si è caricato.
Ah, ok.
Spento per
So now we have the ErgoCAD presentations and the iField presentations, and then probably, I don't remember the agenda is we have a spotlight. Yeah, spotlight on, and then we go for lunch. Okay, so hello everyone, welcome back, and we restart the increment with Lorenzo's presentation on the ErgoCAD team objectives and achievements. So Lorenzo, stage is yours.
Okay, thank you everyone. So those are the contents of the presentation. So as usual, we start from the team. Then I will shortly introduce the project and the objective of the team. I know most of the people already saw those slides, but there are new people joining every time, so it's good to recall what are the objectives. Then I will present the milestones, the achievements, and finally the statistics. So concerning the team, the ErgoCAD team is composed by some team members. So this is somehow the core team, so the people which has active milestones within the framework of the ErgoCAD project, which are working here at the AMI. Plus, we have two members that joined recently, which will be working from Rome, from the lab in Monte Porzio Catone at the INAIL laboratories, which is somehow part of the project, the transfer of our technology into their lab. Plus, we have also the support from Gianluca and Dario from the iField team, which gives support on multiple activities which are linked to the iField activities. So concerning the project, the ErgoCAD team is mainly involved in the so-called ErgoCAD project, which is a project that involves different partners. So there is the AMI, which is our research line, which leads somehow the project. Then there are two other research lines from IIT, so the HSP, which is mostly involved on the activity concerning navigation, perception, and vision. And then the ICAP Tech facility, which is responsible for building the new robots and somehow giving support on the robots hardware. So this is the timeline of the project, which started in 2021 and supposed to last for 3 years. And we have this first demo / review meeting, which has been postponed. So it was supposed to be within this research increment, but now it's postponed to March 2023. So it will be at the beginning of March. So the objective of the project are defined as follows. So the application of ambient intelligence and collaborative robotics for risk prevention in work environments. So we have somehow four key aspects. So the first one is the ambient intelligence. So we need to develop sensor and technologies to collect data from the environment and from the workers and also from the robots. Then the second aspect is the collaborative robotics. So within the project, we want to develop collaborative robots, in particular humanoid robot in our case. And the purpose of those robots is the risk prevention for workers in two main environments. One is an industrial work environment, and the second one is an healthcare environment. So the project has different, in total 10 work package, 10 tasks, main task. So the first one is the identification and implementation of scenarios within the two environments that I just mentioned. And the final objective is to have somehow some demo, some experimental validation of all the technologies that we build during the project. So in order to achieve this validation, those are the main technologies that we want to develop. So we have perception algorithm, biomechanical risk evaluation, navigation and planning, and robots control. And then we have to support activity. On one side, we need to develop some modeling and simulation tool. And on the other side, we need to develop the the hardware, which involves wearable technologies and robot themselves. Moreover, we have an additional task which concerns the usability, acceptability, and social impact of those technologies. So we somehow need to evaluate the technologies in real application scenarios. So moving on with the milestone. So I divided the milestones by topic. So the first part concerned mostly the human, so the estimation of human quantities. So the first task is the design of a library architecture, which should somehow ease all the work we do in different points of our pipeline for estimating and evaluating human kinematics, human biomechanics in general. So this activity was somehow postponed for some research increment, but now it has started. So we have the repository, we have somehow the first pull request, we have an initial structure for the code. So we plan in the next period to move on with this. And as I said, this should facilitate somehow all the processing of data for the next data acquisition campaign that we have planned, both for ErgoCab, but also in general for I feel and also the PNRR projects that we are starting. Then the second one concerned the code for the model-based risk assessment. So the code was somehow released, the first version of the code. I still need to test it, so that's why it's not closed. But in the next weeks, we are planning to work a bit again on this activity. So it's somehow not closed. In the same way, we started this new activity to have some learning-based inverse kinematics implementation. So moving a bit away from what we did in the past, using model-based estimation of human kinematics. So this activity that we recently started. Then we also, the next milestone concerned the use of the dynamics estimation, also what we usually do for the human, but for the model of the hands, since in the past we were part of a project that was mostly focused on the kinematics and the motion of the hands. So we just wanted to try to run also all our estimation pipeline on the hands model. So this is just a simple example. There was a problem with the visualization of one of the link, but just to show give an idea so of the outcome. So we somehow try to estimate the internal stresses on the hands. Then the last task is now moving backlog, which was somehow to try to benchmark the estimation of kinematics, the results we are obtaining on iFeel with the X-Sense technologies. Then concerning the musculoskeletal modeling, we started again this activity, which was removed in previous milestone, which concerned the development of new anthropometric model of the human, since we are stuck since a while with the model from X-Sense, but we want to have our own model to be more free and also to easily generate new models with all the patients during the acquisition campaign. Then concerning the next two milestones, the first one was the objective was to find some muscles where we can find in literature good models or estimation model for estimating the muscular effort, since we are moving on from rigid body models. We want to move on to muscular model of the human. And the second one concerns the usage of also integrating also EMG signals within the pipeline. So from the EMG signals, we want to combine those with the kinematics measurements in order to estimate and the models in order to estimate the muscle force effort. So we define some models, we also acquire some preliminary data, and we'll move on with all the modeling of the muscle dynamics, which is the last milestone. Then concerning the usage of the robot, so we have these two activity on the control of the robot. So during walking, the first one is the implementation of a nonlinear adaptive controller for working with payload. So this activity is moving on. It was started within this increment, but it's still at the design level. And the second one did not started. So the objective is to also have some strategies for shared payload. Working with sharing a payload between a robot and a human. Then we move on with some activity on the motion generation. So we are so the work on generating crouching feature. We move on with this activity, but we somehow got stuck on it. So that's why we started also putting it a bit on apart and try to somehow different approaches to to restart this activity and somehow move out of the local minimum we just reached. At the same time, with Evelyn, she started investigating new direction also on learning-based motion generation. So this is somehow what I just mentioned. So search for new direction for the adherent framework. And so the last activity instead was not carried on, which is the idea to implement some modular trajectory learning. So to add a new trajectory within to start building on a new trajectory in sequence. So concerning the robot design, so we released the code of the hardware optimization after the paper was presented in humanoids. We provide some feedback for the design of the ErgoCab 2.0. We didn't work on this activity, which the idea was to compare the ErgoCab and ICAP 3 robots, but since the robot is not available yet, we didn't start this activity. We finished the genetic algorithm optimization, the development of genetic algorithm with adding also the explicit dynamics of the robot. And we also implemented the first version of the genetic algorithm, which takes into account also the control parameters. So we somehow combine some simulation with all the model generation pipeline. And finally, for the last activity, we start working in simulation with the ErgoCam model. From the next month, we will also have the availability of the real robot. So finally, some milestone for the project. So we create a new web page. So thanks also to Francesca, which took care of this task. Basically, we have a new web page for the project that we'll try to keep updated. And we also basically finalized those acceptability questionnaire that will be presented next by Gianmarco. We also completed all the documents for the ethical committee for the experiments for the ErgoCab project. In this case, we just missed we just have to submit the documents the next month within the deadline. We didn't took care of the task for the review meeting since it was postponed. And finally, we also prepared this demo in Rome, which happened in November. Very quickly, since we have basically 1 minute left. So compared to the previous research increment, we closed 10 milestones, so better than the last one, worse than the previous 2. We got 2 papers accepted that were submitted in the last research increment, and there were no other submission in the last 3 months. And for the statistics, very quickly, I mean, we can observe somehow some plateau around December, Christmas holidays, and also around the beginning of the research increment, which corresponds to the Express finals, where some members were also involved, some members of the ErgoCab team. There are no other particular comments on the next plot, so I will go quickly because time is basically over. I think the burnout report showed the same thing with less activities at the beginning and during the Christmas holiday. And yeah, I think that's it. Thank you.
Any question? Yeah, it was really interesting to see how we're moving towards the buff. So, yeah, and yeah, because this is probably going to be useful, really useful, both for scientific purposes and also for technology transfer purposes. Because if we can clearly identify where the IP is for human processing, it's going to be much easier to also quantify and find values of it.
I think it's also somehow we have more push now because since we are expecting to do more experiments and we will need somehow some tools for it. So.
Yeah, and also now that the ANA Avatar X Prize is over, probably, I mean, we also went back to our working position, standard working spots. Okay, I don't know if there is any other question or comment. Okay, at this point, let's thank Lorenzo again. And now it's the stage of Gianmarco. Gianmarco will talk about acceptability. Yeah, I set the timer so that you have it. I give you 30 seconds more. 20,
Okay.
actually 20. So
It's my. Oh, eccolo qua.
siamo. Okay, so yeah, Gianmarco will talk about acceptability. So Gianmarco, the stage is yours.
So, I think that the microphone is off, right? Like this. Okay. 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 So we started last year, 1 year ago, to understand what is acceptability, and in this image, this could be the future that we could face soon, but we will accept and use the technology of the future. So we try to investigate to understand what is acceptability and how we can evaluate through questionnaire. So today I'm going to show you how it started 1 year ago and what we did for 1 year or in collaboration with INAIL and Ipsos. So the question is, all these technologies that are coming into our society and then would be soon part of our, it is already part of our life. Will it be used for us? Are we going to accept to collaborate, for example, with a humanoid robot in real world? Or, for example, we try to investigate if we will accept to improve reality with digital information, or also if we are going to wear electronic devices if we feel comfortable with it. So all these topics are part of this investigation, but the answer is that everything will depend on human acceptability. So to understand what people think about robots and wearable, we actually started 1 year ago to understand research in the different field, how other people test and quantify acceptability. Then with INAIL, we define an evaluation methodology from a psychological point of view. And we started with Ipsos to create a statistical methodology to have a target information on people that will participate to the questionnaire. After this, we started to create graphic and video material based on the mix of these two different competencies. So the Ipsos questionnaire will be done in two different working sector. That would be the manifatturiero, that means the warehouse worker, and a sanitario, which is the sanitary, so hospitals and people working in hospital. The target of the questionnaire, as I said, would be all the worker inside these two different working field, and there would be 850 people interview, so 500 from the warehouse field and 350 from the sanitary field. There is a different methods. There would be two kind of interview. One, it would be face-to-face on site, so people would be interviewed through computer and through the recognition of the facial expression, for example, during the questionnaire. And it would be also another approach that would be online and would be a bit different. So the people have been chosen also by the geographic area gender, and age. And the maximum, the interview will last 20 minutes. But what is the focus of the research? Which are the information that we expect to collect with the questionnaire? We want to understand if the aesthetic of the robot will impact acceptability, for example, of ErgoCab. And we want to understand if the aesthetic and the perceived comfort of the wearable system will impact the acceptability of the new Sensoride working suit. The questionnaire will be divided in 5 sessions, and every session has a different, will test different topic. So the session 1 will target and evaluate the technology acceptance, and will evaluate the perception of the biomechanical risk of the worker. So this will be helpful to us to understand the technology readiness of the people and the technology acceptance. What does it mean? It means that there are different people that have a different knowledge and acceptance of the technology, from the innovators, but there are also people that doesn't like it, have fear of technology. So we need to understand what kind of people are doing this questionnaire. In session 2, there will be the evaluation of the robot aesthetics through comparison in a real-world scenario, hospital or warehouse, and evaluation of the robot facial expression. So we decided, and we work a lot to find the 3D model of the robot that we will insert inside the world scenario. This robot are Atlas, Agility, ErgoCab Valkyrie, now Telos Baxter R1, that will be inserted in these 2 scenarios that we created in a 3D environment, so the warehouse and the hospital. Now in this case they are not complete, but cutted. The image is not complete. Then we will test in the second session the facial expression of the robot, and we did this in collaboration with the design studio that also designed the robot. And we will try to understand which of the concept would be more easy to understand in a working environment, for example, which would be more immediate to give information to people that are collaborating with the robot. In the session 3, we evaluate the perceived usefulness and emotional impact of the robot during a real collaboration task. So, for example, we are creating 2 different illustrative videos. One in the context of warehouse. In this case, Gianluca was our model, and it will perform with the robot job lifting collaboration and object recognition inside boxes. And the other is the hospital, in which I am doing the patient, and so the robot will perform patient lifting, health checkup, and understand and satisfy the patient need. In the session 4, there will be evaluation of aesthetic satisfaction, comfort, and functionality of the suit. And we want to understand if people are interested in using the proposed technological solution. So we create 4 different videos, one with an iFeel suit, and one with a normal working suit, which would be maybe our working suit 2.0. And we are going to test how people perceive this object, how people feel like to be monitored with data, and so we want to. This would be useful for us to design the new suit as well. In conclusion, what kind of information we would like to. We think that would be useful in the future. These questions are really useful to understand. The evaluation of aesthetic will help us to design a better robot used in a real-world scenario. The evaluation of human emotion will help us to design better robot collaboration strategies. The evaluation of a robot facial expression will create a better human collaboration. And at the end, the evaluation of human perception of wearable will help us to design a better device. So thank you for your attention. For any question, I can share any information on the questionnaire or whatever you like.
Any question for Gianmarco? Don't be shy, yeah? Punit, you wanted to ask something? Ah, no. So the... you. Eh? Okay, so no, I think that this is a really promising direction. Including the acceptability into the design phase is a unique, really the unique component of the current state of the art. So if we want robots to move from the labs or the, let's say, industrial production chains, we really have to understand what people accept or not. Okay, and I mean, my dream, if you want, is that the acceptability indices and cost functions can be put inside optimization problems. Okay, that then as an output they give also how the robot should look. Okay, so if we were able to then reverse engineer what people like and what people dislike, okay, we might put these as cost functions, okay, into the co-design phase. So this is a dream that probably I'll be dead, but yeah, but yeah. Okay, so I don't know if there is a comment based on this. No? Okay, great. So from the audience, no? Okay, so I think let's thank Gianmarco again, and we move to the...
Thank you.
I feel. To the wearable technologies that we are developing. So for those connected in the cloud, it's more or less 4 years we are working on this. Oh, probably less than 4, like 2.5. Yeah, no, or 3 years, probably 3 years. Yeah, 3 years. Yeah.
We are also working in this direction that Gianmarco just showed with some tests that we are performing. So because we have the questionnaire, so this to be a nice output to share as soon as we finish the test.
Ah, concerning the medical applications, you mean? Or
yeah, exactly.
Okay, I see.
But let's say wearables in general.
Yeah, wearables in general. Yeah, okay.
We ask people that they are doing some test to fill a questionnaire. Does it work? No, I have to add it.
Yeah. Funziona?
Yes. To fill the questionnaire, so then we can see if it works. We can get some feedback for this.
Yeah. Okay, Enrico.
Okay.
This is yours.
So good afternoon, everyone. Now, so let's see what we have done in the I feel. So just first of all, for the newcomers, especially, what is I feel? So the idea is to create a set of wearables and software capable to retrieve data from humans and then be able to study, to understand also the physiological aspect of the humans, so the fatigue and stress analysis in general. Then we also use, I feel, for teleexistence, for an avatar and many other things. But the aim at the moment is more focused on the medical aspects and industrial aspect. Already finished? Okay. Too fast. No problem. So also on top of that, we want to give also feedback to the humans in order to give, let's say, some direction on some rehabilitation exercises, for instance, or whatever is needed to give feedback to the human. Out of it, since the technology readiness level is so called, you can check online what it is if you're not familiar with it, is a little bit higher than normal research that we do in our lab. We also have the idea to create a spin-off. So basically, we want to use also the transfer technology in order to move our research into the real world. We are focused at the moment in healthcare. We are doing some tests. I will explain you probably not this time, but the next time. So what exactly we are doing. You see here all the market segments that can be used by a field. There are many, but now we are focused on the healthcare in general. Okay, so here is a list of objectives that we had, the milestones that we had in the last research increment. The blue ones here are the one that we carry on from the previous research increment. And this one are the new ones. So we go through one by one. This one are the milestones related to the spin-off. Okay, so we start with the first one. So the idea was to design hardware for the new acquisition unit for stretchable. We will have an insight later with Gianluca, but just to, I don't want to spoil anyone. So just to give you an idea, we have the boards, we received them, we test, and they're working fine. You will see the results later with Gianluca. Then the second one was to create a first prototype of the ESB Wi-Fi bridge. So the idea is to move from ESB, which has a small range of communication, to Wi-Fi. And for that, Aditya did actually his thesis. We managed to reach a certain level, so we didn't finish it, but we managed to have the first integration with Wi-Fi. We still miss the ESB, but now Dario is carrying on these activities and changing a little bit. So we decided anyway to close this milestone to move on to a different, say, path, but with the same goal. So the third one was related to the submission of the ethical committee to the ethical committee approval for Villa Beretta. Villa Beretta is a rehabilitation center that we are working with in Lecco, in the north of Italy. So we are preparing all the documents to be able to do some tests with the patient. We are almost there, so we managed to do a sprint in the last few weeks. So the protocol document is almost ready. We have the user manual of the technology, and now we aim to submit everything in February. So within a few weeks, we should be able to finalize everything. Then we had to test the shoes against the red norms. The red norms are the radio norms, so that's very important in order to go to the market, because without the CE marking, you cannot put any device in the market and nobody can buy it. So we managed to do the first step, which is to do all the tests, and now we are compliance, let's say, with all these norms you can see here. So if you are interested, you can go through internet and check what they are, but the European norms that you are obliged to respect if you have this kind of devices. Then the milestone 5 is start the activity for the new field shoes. We got some, let's say, some quotations, but then we are a little bit stuck at the moment because we are waiting for new quotation. This is a difficult task because we have to explain every time to new companies what we need. They have to understand this. It's not easy to explain. So we have a lot of iteration, and we waste a lot of time in meetings with them and try to understand what we want. Mainly, we are going two different directions. One is new medical devices, so new medical shoes, and the other one is safety shoes. You know, let's say, following what you saw with Lorenzo for ErgoCab, so the direction of medical and industry. Then the milestone 6 is to reach calibration results comparable with rigid. Many things have been done. So we tested the sensor, we do a calibration, and we study a lot. I don't want to spoil it again, so Gianluca will give you more info in the next presentation. Then the 7 was to get the first prototype of the new FE suit. So we got a little bit stuck on this because the activity that we started with Marisa Botti did not work as we expected. So we had to stop it. We didn't see, let's say, the goal, the feasibility of what was proposed in the next few months. So we decided to stop this activity and move to the next, let's say, using a wired system that Dario is following up at the moment. Then we had to define the network architecture of the bridge. This one was not done, so the thesis has been concluded, so this task has not done, and then we stop it, and then we will start again this activity as soon as we have all the system in place for the hardware and the firmware. Then we have to manufacture new Wi-Fi nodes. So we have other 25 nodes manufactured, so they are in the lab. We need to just assemble them, and we are planning to do it soon in the next few weeks, but they have been done finally. So we have more nodes for more suits available soon. Then we have to create a firmware skeleton for the field-wide version. So this is a new version that Dario is working on. We create this firmware. The problem is we had a little bit issue with the hardware, so we are waiting now for the test. The firmware is there, but has not been tested, so we need to test it as soon as possible. Okay, then moving on, we have to add a wireless feature to the field-wide suite. So basically, that's the idea is to create this bridge. So we want to add a Wi-Fi connection to the suite. So we did some work. We investigate how to do with the 2 cores because we are using a new microcontroller with has 2 cores. So we have to understand how to use them, how to write the code for that, how to interact, the interaction between them. And then we had to add also the ESB support, which is the one that is used in the current version of the nodes. So we did some work, but then still we are a little bit stuck waiting for the Wi-Fi module because the Nordic, which is the microcontroller that we are using, said 1 year and a half ago that they were, let's say, providing soon with Wi-Fi capabilities, but so far we didn't see any something available in the market. It's ready, we know that it's ready, but it's not in the market. So we are waiting, this should be in the market soon, hopefully in February, they said, but let's see. Okay, then we have to create the Wi-Fi version of the field driver. So this is a software part. We are on hold with this because we don't have the hardware and the firmware ready. So what we thought is to wait for the hardware and firmware to be ready and then move to the software part because otherwise we cannot test. So it would be a waste of time in this moment. Okay, then we have to create a new version of the calibration setup. So here we move again to the stretchable. Again, I don't want to spoil you because Gianluca will show you some nice result that he obtained. But then we have a new setup thanks to Punit. We create a new piece of hardware, and then we create a new setup, and then we have to test it. But again, Gianluca will give you more information on this. Then we have to write the master thesis, not mater, but master thesis, Aditya. He managed to do it, so he finalized his project. He didn't complete everything, but he managed to create, say, enough to create a master thesis. He discussed it. Unfortunately, we couldn't follow it and defend it, but we couldn't follow it because it was not streamed online. So I don't know why, but we couldn't follow the discussion. But okay, he managed to do it. Then milestone 15 is to define a concept for the enclosure of the hardware of the new version of the shoes. But since we are a little bit stuck with the supplier, we put also this on hold because it's a job that has to be done together with the supplier in order to do a proper job and work together to find the final solution. Then I think this is the last mile for IFIL, finalize the risk assessment for the IFIL shoes. This is very important for the game, for the CE marking to be able to go to the market. So we have to find a risk assessment, to create a risk assessment, so the risk that the people can have in case they use the technology. And this is also important for all the tests that we are doing in rehabilitation centers, because otherwise without this, it's difficult to pass the ethical committee and also to the minister submission. So for this, we got the risk assessment. We got also some very important, let's say, information or feedback from the external company that did this risk assessment in order, let's say, to comply in the future with the next version of the hardware with all the requirements that they are, let's say, required for the CE marking and to go to the market. So we should apply also this, and this will, let's say, what we need to do is create a better hardware, slightly better hardware, and change a little bit in the firmware some information and create a proper software for that. So there is a path to follow that we need to discuss. Okay, related to the spin-off, instead, we had 2 milestones. The first one was to revise the IFIL web page. So there is the IFIL web page that is working now, but the problem is we cannot access and make a modification. So this is something that was working for a while, but then suddenly stopped again. So the idea is to move to an external server. Then the second one was to submit to RoboIT, but unfortunately the proposed project, which is the IFIL stretchable, did not pass initial screening. So at the moment we don't have to apply for this. This is an overview of where we are, I mean, what has been done and the status. So here you see quickly the status of all the milestones. And this one, unfortunately, they were not done both. Statistics, we are in line with previous statistics. I see the graph going up as usual. Here a little bit, I think we are increasing a little bit the average and the median, but still we are not too bad, but I think we should improve a little bit few things. But yeah, in general it's fine. I think again here for the release report, we are in line again like the previous one, 83% done. So I think yeah, everything seems to be in line with the previous one. Okay, so that's done.
Any question for Enrico? I was just curious about the fact that yeah, it makes sense now to put on hold the firmware, the Wi-Fi firmware for the module. So I think that as soon as we will get the hardware ready, we can think about it, right?
Yeah, the point is we need to wait a little bit, in my viewpoint, for Nordic, because it doesn't make sense to add a different.
I understand.
For Nordic, they said last September that they were ready.
Okay.
Then they postponed it to December, and then January, and then we really hope that it's time, because then it will be much easier for us to implement it, to integrate it.
Yeah, yeah, sure. No, it doesn't actually make sense to to develop sounds.
I hope we are talking about a few weeks or months. So
okay. Yeah.
That is in this task. So.
Okay, so let's thank Enrico again.
Thank you.
We move to Gianluca's presentation. Guys, we have 5 minutes in advance with respect to the shell. It's incredible.
The sound.
No, because so it's you already started, so we're. I wrote ICT, but they didn't. Actually, probably. Yeah. I know they are not answering. No, I wrote Mattia, but that means since we are 4-5 minutes in advance. In the meanwhile, you can start connecting. Yeah. So laser pointer laser.
Yeah, but still it's not.
You see, you can use the mouse. Okay. I see. Okay, so Gianluca, we talk about stretchable insole chapter 2. This is something it's been a long time we'll be working on. I know that there are some amazing ideas and actually results that are also converging towards patent and publications. So Gianluca, the floor is yours.
Good morning, everybody. So as Daniel anticipated, I will talk about the second version of the stretchable insole hardware. And so I call the presentation Stretchable Insole Chapter 2. Here the agenda. I will give you a little preface for those who do not know still the project. Then I will focus on the main question, why a second hardware iteration? I will explain the technical features, and I will show the first calibration tests. And then in conclusion, I will discuss about possible next steps and show a simple first demo. Okay, let's go with the preface. The project goal is to design and calibrate a capacitive sensor-based stretchable insole that in order to measure the pressure distribution over the foot surface. Why to be used then in the context of the iFeel project. Why second hardware iteration? It was April 2022, and we had in the lab the first insole prototype, but still, it had some limitations. First of all, the trace length was not optimized to be inserted into any device, such as shoes. The interface to the data acquisition unit was really fragile, and that was a huge problem. The analog to digital converter were too close, leading to measurement noise. Actually, we managed to reach acceptable data, reading from one converter at a time, but we had to reduce drastically the acquisition frequency. At that point, we had two choices: trying to reach a first MVP and a first working demo with the available hardware, even if not imperfect, or starting from scratch, from zero, to have a solid hardware platform to work on. So in the end, together with Daniele and Enrico, we decided to go the long path. And so that's why today I'm here glad to present you the stretchable insole 2. It is still a stretchable PCB integrated with a rigid acquisition unit. And it features 2 copper layers printed on TPU. One with 24 capacitive sensor pads. The other layer, an improved shielding layer to protect against noise. It has meander-shaped traces with, that can make the design robust against mechanical stress, and with optimized length to fit in a shoe. It has robust, now different from the first prototype, robust rigid stretch connector for intensive testing, and an optimized ADC positioning, the 2 squares you see there, to avoid electrical interference. The acquisition unit acquired it at 100 Hertz, and it's all wireless. And it features also a new IMU, a Bosch VHI 260 AP. This design has been patented after a long process with the IAT Patent Office. Let's give a few more details on the IMU. It is the BHI 260 AP from Bosch. It has been chosen to substitute the BNO 055, which has gone obsolete, and is the same used by Dario for the iFeel suit. We did a hard work to integrate the drivers of the sensor into the iFeel firmware. We spotted out a bug in the driver for the communication of the sensor to the host microcontroller. But in the end, also thanks to the help of Dario and the support of Riccardo, we managed to solve it. And now here is a first demo. We can show real time the orientation of the device on the iFeel software. But you may ask, why having an IMU on an insole? To answer this question, I will cite the work done by Claudia with the Associazione Italiana Sclerosi Multipla in the context of the iFeel shoes experiment. In that case, medicians from ISM asked us to calculate some so-called KPIs, which stands for key performance indicators, quantities that are fundamental for their daily working activities for diagnosis with patients. And in this specific case, for the shoes, or as it well for the insole, here are some examples. So cycle duration, cadence, so the number of steps performed in 1 minute, also stride length, so the distance between successive points of initial contact of the same foot, and so on. And for these KPIs, IMU are needed. Let me say that in iFeel, we strongly believe that these KPIs can be useful to drive our technology into a product. But let's go on with the testing phase. As soon as the hardware arrived to the lab, the first thing was to check if the sensor respond and they were without noise differently from the first prototype, and the feedback was good. So we proceeded. We proceeded with the running of the first calibration tests. Let me say 2 considerations before showing the results. This is a capacitive-based sensor, so the electric material choice is really important. The second, as per every calibration, a ground truth is needed. In this case, for this initial test, we decided to use the force platforms, giving the force, the Z force, so the force in the Z axis. The first tests were done with some peak dielectric films that you can see in the left image, but they led to poor sensor responsiveness. As you can see in the right graphs, the sensor response are shown in the above graph, while the force given by the first platform in the below image. We tried to change, and we got better results with the thinner dielectric film, and you can see the difference with the sensors that are much more responsive with the same force applied. Again, here the comparison. So we decided to proceed with the first running of the optimization algorithm which matches the capacitance to the pressure. And the result was pretty promising, since the blue curve that represents the measured pressure is fitted quite well by the sensor curves. What could be the next step? Increasing the pressure range to match real scenarios. These pressure values were quite low. How to do this? Well, Punit did a great work to create a new customized support, calibration support for the insole to be used inside a pressurized chamber. It has been designed and manufactured and now is available for testing. Other possible new steps apart from calibration for the hardware, take note about possible improvements for a third version. We already have in mind to try with silver ink instead of copper for furtherly increase the mechanical robustness. And then maybe define a demo and a minimum viable product. So maybe also in this case, choose the most important KPIs and define a possible product. Finally, I will show you a simple but effective demo. First demo of the product. So you can see here pressed different parts of the sensor layer. What you can see in the right are not only the capacitive values, but already I put the coefficients coming from the optimization algorithm. So they are pressure values. But still we have to improve a lot. Thanks.
Nice. You kept the video for the cool. I didn't know. I didn't see the video before, so it was really, really cool. So any question for Gianluca? Yeah, Silvia. Hang on a second.
So I wanted to ask, you mentioned at the beginning as like motivation, the KPI. So by passing through from the 6-axis photon sensor to the soul, you basically give up the tangential, the possibility of estimating tangential force. Do you think that is totally okay, or in the future it could make sense to try to investigate if this technology could be extended also to estimate tangential forces?
Thanks for the question. Yes, for sure. For this regard, we also are the advantage of the insole is having a very portable device. Maybe this can be a possible solution. We also discussed with Daniele some possible ideas to implement this, but also a possible in parallel path is to decrease a lot the portability also of the FT shoes, because they will be for sure better in measuring that type of quantities.
Okay. Any other question? Yeah.
Okay, so just a comment related to the patenting. So you saw that it's patent, it's not patent yet. So I mean, we submit, so it's pending. So we submit the request, and we are waiting now for the European, no, Italian actually. So we need to be sure that they accept it. In general, anyway, it's something that I wanted to show you today, but there was no possibility to do it. In general, it's possible for everyone to patent the activity that you are doing. So it's something that so far we didn't do in our lab, but then I think it's important then in the next future to discuss about that, because everyone can do it and can be quite interesting for you as well, because before publishing, it could be that it's interesting to protect your research. So if you are, let's say, if you think that you did something innovative, something new that can be used in the market and you want to protect it with your name and the name of the lab, of course, then I think we can have a discussion and I can explain a little bit how it works, the procedure to follow, and what we can do for that. Probably we should organize a talk also with the TT, the IITTT, in order to give more information on that. It will take some time, so it's not 10 minutes presentation, it could be a couple of hours, maybe 4 hours also to understand exactly how to do. But keep in mind that it's possible to patent your, to present the request for patenting your activities, and it could be for some reason, could be interesting for you. Then if you want more insight, we can have a discussion or we can present properly this activity.
Yeah, the question is what can be patented. So yeah, I'll say both. We can patent both algorithms and also hardware. So right now we had a patent for Onkamotsu, I guess, that went through, and also now we are submitting also the calibration algorithm for the iFeel. So usually patenting, as Enrico was saying, it's something that in the beginning of your research you don't give value to. At the end of your research path, you start regretting not to have done it. Okay, for multiple reasons. One is for sure the possibility of somehow making a spin-off out of the research, which is somehow a potential direction. Another thing is also, if you want, economical reason. So people using the patent then have to pay a certain number of royalties, and then IIT structures this with 33% on IIT, 33% on the research line, and 33% on the investors. So actually you get paid back. Okay. The inventors. Okay, so the inventors, okay. Inventors. Sorry. On the investors, the inventors. Okay, so get paid back. Okay, so there are multiple reasons to patent something. Okay, so that's also I strongly advise. We should organize with Enrico and Silvio probably a seminar on this in order to make people sensitive to this point. Okay, so let's thank Gianluca again. Okay, now we have a spotlight presentation from the cloud. Mohammed, do you hear us?
Hear me?
Yes. Great.
Can you see my screen? Wrong
No.
screen.
No.
Okay.
Let's see how it works. I don't know if, because now, I don't know how it works. ICT might help now because we have only one.
We can see it from the cloud, actually.
Okay.
Can you see
That's cool.
my screen now?
Yeah. Now I see
Okay.
yourself. So Stefano is smanettando. So Stefano is touching things. So now we see yourself. Now
Okay.
we see
So let me.
ourselves. So correct me if I'm wrong, Mohammed. You're presenting from Sudan, right?
Yes. Yes.
Okay. Yeah.
How about now?
This is really cool. Still 1 second. Can you get back when we saw Mohammed? Yeah, now we see. Yeah, this is called domain randomization in in the reinforcement learning literature. Doing things at random, make things right. Okay, so Mohammed, yeah, 10 minutes. The stage is yours.
Okay. Thank you. And good afternoon, everyone from Sudan. So I will be briefly talking about what we did for the joint lab with Honda in this research increment. And for those who are new, the idea of the joint lab is a technology transfer joint lab that is concerned with transferring the knowledge of the lab in terms of grasping telemanipulation and control to robots that are provided by Honda. Currently, we are able to run most of the stack of the software that we have in the lab that we used for the avatar system on the Honda robot, on one of the Honda robots. So the walking controllers and the retargeting IK, on specifically the E2DR. And we are aiming to do a Genova Tokyo telemanipulation demo, as well as to start working with a new hard model that will be provided in the next update meeting. Okay. So more in detail, in the shift task, we basically reviewed and updated the Proto 2 SIM, which is the name of the robot that is provided by Honda. We reviewed the URDF models to make it compatible with YARP and with our software infrastructure. And then we successfully ran the walking controllers on this. And okay. In terms of the URDF model, we managed to add some IMUs as well as FT sensors to run the whole body dynamic estimators. We reviewed some of the inertia values for some of the smaller joints, as well as modified some damping properties of some of the control joints. And with this, we were able to basically see all the YARP plugins running. And then we moved to do some slight low level, sorry, it went too fast. Okay, so some low level position gains. Okay, yeah, so some low level position gains tuning for various joints. Some of the joints we managed to, well, we discovered some weird joints limits that led to some bad tracking behavior. With time, we improved the tracking on various joints up to some of them with almost perfect tracking. This allowed us to run the position walking on the E2DR. This is the E2DR, and I will let the robot walk for a bit. And this is with the current master branch of the walking controllers. Of course, running this allows us also to run the I-feel walk-in retargeting with the shoes, which is the next step that we are planning to hit. In terms of tracking behavior and errors, we have very nice tracking errors on most of the joints except for the shoulder, the left and right shoulder joints, due to some mismatch in joint limits that we are trying to fix. And you can see from these plots. Yeah. In terms of the center of mass quantities as well, we have very nice tracking when performing the walking. And finally, some comments on what we did. We are, as I said, we are running the current walking controllers. We did some changes to the planner parameters and the controller parameters to make it match the E2DR. It's now currently stable and reproducible, and there is a BR in the projection MI Honda repo. And we are currently working in integrating the rest of the pipeline of the avatar system before the demo that we are planning to do. In terms of the future plan, the main point would be the new hand URDF that we should obtain. We should have obtained on the 18th of January, but still we didn't. And then I am currently writing and finalizing the first annual report that is to be submitted to Honda for review before the deadline on the next update meeting, which is on the 3rd of February. Yeah. With this brief, I say thank you.
Okay, let's thank Mohammed. Yeah, Mohammed, really nice. I tell you the truth that I was impressed. It was Christmas time when I saw the E2DR walking. We were struggling a lot to this position gain tuning. So congratulations to you, to Lorenzo, and anyone who helped into the process. Yeah, really, really cool. It's really nice that we can port our avatar system onto other platforms, which are so different. And actually, one of the ideas is with the Honda guys is to make the demos from Genoa to Tokyo, okay, real time with the system. So it's going to be exciting. Any other question, comment? No? So let's thank Mohammed again. Mohammed, I know that you are planning to get back soon, so we see you each other soon.
Actually, my flight is today in the evening. Yeah.
So great. You're on the aircraft.
Okay.
Cool. Okay, nice to see you soon, then next week.
Yeah, see you soon.
Okay.
Gabriel.
Okay, now it's Francesca. Yeah. And with this, we finish the morning session. And then the afternoon session is going to be closed for the cloud. So for the AMI people, you will receive another link. Is this right? ICT, sorry? Yeah. Ma per il pomeriggio hanno un altro link o buttiamo fuori quelli? Come funziona?
Ho pensato semplicemente che entrano quelli che devono entrare e chiudiamo la stanza.
Okay. So no, you don't receive another link, but only AMI people will enter. Then we close the room because classified informations are going to be discussed. Okay, so yes, Francesca, we talk about. Does the cloud see the Francesca's monitor? Anyone in the cloud?
Yes, yes.
Yes.
Thank you very much. Yeah, Francesca, we talk about the simulation of the research line. Yeah, Francesca, stage yours.
Thank you. Today I'm talking a little bit about what we did in these 6 months and what we can do actually now to for your projects and for your presentation and so on. So let's start with our lab, the communication that now we have for our lab. And we now have a flyer that we were going to use for all the events and also for when some people can actually happen that a lot of people just come to the lab and Danny do some presentations. So it's useful to have something to give them when they leave. So we we already printed it. We have it in our lab and we already use it for a couple of events. And this is what we designed, and it's all following the branding identity from IIT, of course, and the colors and the fonts. And we managed to put all the information about the different branches and also the joint projects and the spin-off. And we now are talking about the website that we changed a bit. And here are the unique visitors. We have data only from August, because before we don't have it anymore. They didn't give it to me, so they didn't have it. And here, I don't know if we can follow the link, and if you can see it, I guess not. That is not possible. Anyway, I will share these. Actually, you can search the website for yourself, but I will share the slides with all the links. And actually, in our website, we changed a lot in the homepage. Actually, it's more responsive too, because a lot of people just watch it from the mobile phone. And now it's easier to use it, but we cannot change it completely because we have a fixed IAT has rules and has a fixed platform to create their website, our websites, for all departments. So we cannot change it completely. We cannot modify it too much. But actually with Gabri too, we changed the composition of the iron cup page, for example, and after we will do also for the others research branches, and we started with kind of a general information, and we went vertical to we went down to just explain more what we are doing. Actually, the website is the most detailed thing that we have that is public. It's what we want to achieve. Actually, it's what we're gonna become. And for the I Feel project, we did a rebranding. So we changed a bit. This is the old version, and near it there is the new one. And please use it for the slides, use it for everything that you need. And I have it, so just send me a message, and I will give you all the versions that we have, because we have a couple. Now it's actually it's more balanced, and there is the chance also to use it, use also the writing part, the logo type. So it can be really useful. And for the colors, we started from some mood boards that Gianmarco did before, and I developed the colors and the concepts. And we did also a version for a future industrial, for an industrial part in the industrial setting. Thank you. We did another flyer also for I Feel, and here it's already printed, of course, it's in the lab, and we already used it, and we will gonna kind of change a little bit we're gonna change some image too. Actually, we were gonna remove the part that it's without the cover, the haptic, and some other little changes maybe now that we have some ideas more. Okay, I cannot show you the website, but actually there is a website that we cannot modify. and we set it up a kind of template for presentations too. Here we did also a video that is not okay. Anyway, here we go. No, okay. But we did 2 videos for ICRA, actually, and we submitted it, and we are waiting for a response. Actually, this is a quick shot. We didn't, in this case, we didn't have time for the shooting, so I actually just animated some pictures that we took, and put it some contents. And this is instead is for the video that we sent it to ICRA of the Iron Cub and aerial research line. And here it will starting with the simulation, and after with a timeline of events that the evolution of the of iron covers, like Punit was saying before. And this is the short version. There are other things inside, of course. And yeah, actually, this is in SharePoint. If anyone wants to see it, just message me. And this is the for the ErgoCub project. We did flyer too. And that we use it for the email event that we had made in email. And we also did a website, but actually we are waiting for the kind of official release of all these. So it's there is, and it's give the basic information about the project. And now the social media. Actually, this is the part that I worked less on all these things. And but here it's what we have until now, and for sure I'm gonna put in from now on. I will gonna put more effort, and I have already planned things that before I didn't have. So now the page visitors is just the people that visit the page, not that see our content, because our content are spreading around, and it's different. Actually, we have an idea of course, the quantity, but also the location. Mostly are Italian, of course, and a lot are from Genoa, probably from IIT. But and we have also someone from Paris, and some different Istanbul, and some other cities from Italian cities. And the followers, we are like 814, today 16, I guess, but we have only 14 employees. So if you like, please just add to your, if you have a LinkedIn page, just add, you don't have to delete the IIT page from your employee, how do you say, list. You just add also the page from artificial and mechanical intelligence, if you like, and you will be connected to that page too. So you will be connected to both page, kind of double job you will gonna have in the same time. And here the location of our followers are pretty the same. Some more from India too, and Germany, and it's a little bit more kind of, there are a little bit more people from Germany, United Kingdom, and some from New York City too. And but we have to kind of trying to spread more outside Italy. And here are the industry that the people that are our visitors and our followers are working in. So we actually, for these, we are in line, because there are a lot of research services, of course, but there is also higher education and ET service and consulting that I don't know, but yes, it is. But there is also machinery manufacturing and electronics manufacturing, aviation, and so on. So I guess we are in the right sector of now we are in the right industry, actually. So Facebook and Instagram, sorry for the Italian, but it's what I tried to change in English my Facebook, but I didn't had luck for that. And here we have actually, of course, for the Facebook page, we opened 6 months ago. So it's 10% of respect of before. The increase is the 10% because there is no before, there is no past for this page, actually. But here is what we have for these 6 months. And actually, Instagram, it's more, it's almost it's visited the double. Okay, I'm trying. There are kind of, the percentage is the double than before. So I guess it's fine. And the followers are like 4 times more than the 6 months before. So from July to now, we actually had 4 times more followers than the 6 months before. So from January to July. So it's not bad. There are not too many, but we don't use any we do not pay any contents. We do not advertise any contents, and we actually didn't have too much time to just completely work on it. So it's not bad.
here the page visualization, and here there is the gender and the age. Actually, when in the Instagram, the woman just grew a little bit, a couple of points from when I started, but actually these are what we had before, and this is what it still is. So we just it didn't change too much in these 6 months. And here we have the places where these followers are from. So most of them are in Italy anyway. And this is our kind of the idea for the upcoming post. I started already, but there will be posts that will show your papers, and they will give the links. And there will be I Feel posts that will be posted on I Feel LinkedIn and in our other social media. There will be videos and reel connected to our work and our events. And there will be like some pills from the research branches, like not kind of speak about a particular thing that we are doing or we did before, so to just inform a little bit on what we are doing. So that's it. I don't know if I'm in time. Thank you.
Yeah, we are perfectly in time. Any question or comment for Francesca? No? Yeah, Silvia. No, I think nobody raised his hand.
So, are you getting comments? How there are people interact? Because in the past we had some hilarious stuff, typically not on our social media, but whenever our contact went on generic publication, you got really strange comments, and somehow also hilarious. So I was wondering if you had.
No, okay. Actually, no. No, for now not, but we are growing, so it will happen, of course. It will happen. I'm ready for it. But actually on YouTube, I saw that we actually blocked the comments. And but it's a thing that we will not, we cannot do in the other social media. So we will have to deal with it. We'll have to deal with it, and we will we actually have also the communication that it's the IIT communication department that work on it every day, so I guess it will not be a problem.
Yeah, I remember the first time that we released the balancing, the first balancing. It was 2000, probably 14. It went on Repubblica.it, and there was this famous comment, "Grazie Francesco Nori," that actually he has a talk tomorrow. Francesco Nori, advertising, yeah. So Grazie Francesco Nori is teaching robots to kill kids in Pakistan, or I don't know, for wars, something like this. Yes, it was really, yeah. Anyways, so I think that yeah, the morning session is over. Thank you very much, Francesca, once again. And there was something I wanted to yes. So for people, it's important for people that got papers accepted, please start preparing videos, repos, dissemination. This is really important. Okay, code, it has to be clean, videos with good audio, and yeah, so so this is really important. Okay, so let's meet at 2, and thank you very much for anyone connected outside the research line, and we can see each other in 3 months where we'll do this. Okay.